This is another ladder problem where in addition to the hanging mass of 80 kilogram, you also have the mass of a ladder. So the mass of the ladder is distributed along this its length. So if it is 40 kilogram uniform ladder, the mass would be acting from the center over here, and basically it's going to be acting down. So that would be F equals to mg, that's acting down here. And for 40 kilogram, you have to multiply by 9.8. In this case, just for simplicity for my brain, I would use g equals to 10 meter per second square. I mean, in your case, you have to use 9.8 and you have a calculator. I will just use a rough math here. So forgive me for that. The height at which the ladder is touching on the wall is given as h equals to 4 meter. So whenever you're reading the question, just go through the question and try to realize what is given. For example, over here you are given 5 meter long ladder. So you have a triangle here which is basically acting like this, right? And you can realize that basically this is 4, 5, and therefore this must be 3 using Pythagorean. This is an interesting triangle here. And because the weight of the ladder acts from the center of this point, center of the ladder over here, that is center of the mass, therefore, when it comes down, it's going to be acting at about the distance of 1.5 meter. So if the weight of the ladder tends to rotate it clockwise, right? So guys, you can probably see that the logic over here, the force that's acting at this point on the ladder, if there was no wall support, then it would be basically rotating it clockwise. So that's the clockwise rotation that you would be seeing, right? So, and that would be negative torque that we'll be considering. So because of that weight, the negative torque negative torque is given by, let me call that tau 1. Okay, if the weight that is acting over here is gonna be 40 kilogram, then the torque due to 40 kilogram, right, is given by the force, which is 40 kilogram, right, times m times g. This is mass, and there is gravity, acceleration due to gravity. I'm taking 10 meter per second square. So 40 kilogram times 10 meter per second square times the distance over here is gonna be 1.5 meters. So that is the torque because of the weight of the ladder. So that is clockwise torque. All right. Okay. The other force that's basically going to be acting on is because of this hanging mass of 80 kilogram that's at the edge of the ladder near the wall, right? So we assume that it's almost touching the wall, so there is a little bit of error, but that's not a big deal. The idea is that there is a force acting at this point, acting downward. So that's another torque that's acting because of the 80 kilogram hanging mass here. So that's going to be equals to, so let me write that this one is tau 1, and the other one, the torque due to 80 kilogram that's acting from this point of support over here. You can see that that's going to be acting 3 meter away. That's the perpendicular distance here, 3 meter away from the point of support. That's going to be tau 2 equals to 80 kilogram times 9 point, sorry, oh, not 9.8. I'm going to be working with the 10 just for simplicity. So that's gonna be 80 times 10 meter per second square times the distance over here is gonna be 3 meter. So so the total torque, right, the total torque is gonna be 40 times 10, 400 times 1.5. So that's 4.5 is about 600 Newton meter, plus that's 800, that's 2400, Just do the math yourself. There is 9.8, but I'm using 10 just for simplicity, Newton meter. This net torque or total torque, try to produce two clockwise rotations here about this point of support here. Okay, so that gives me the total torque is 24 plus 6 is 330, and there are two zeros, Newton meter. So that's about 3000 Newton meter of the torque that is in this case clockwise. And I'm trying this pad for the first time, so forgive me for my handwriting. I mean, you know, my handwriting, it's not the greatest in the world. You got the idea. Now there is another force that is basically going to be acting at the point of contact, right? I mean, obviously there is a force of as you see from the previous example, right, at the point of contact over here, there is gonna be, you know, force that is acting on it, but they will not rotate your ladder. So therefore there is only force that is trying to rotate it clockwise is gonna be the force, horizontal force, right, F, and that is the magnitude of the force that the ladder exerts on the wall and the wall exerts on the ladder. So, you know, vice versa. So that force is acting from this point over here, right? The perpendicular distance is 4 meter away. So therefore the this basically, the tendency is that if you assume there is nothing else, this force will try to rotate it anti-clockwise. So therefore the torque, right, and this is anti-clockwise torque. Again, my handwriting is not great. Anti-clockwise at this moment, anti-clockwise torque, that's gonna be force times the perpendicular distance is 4 meter. So as you can see that you have anti-clockwise and clockwise. This is clockwise torque, that was, you know, because of two weights, and this is anti-clockwise torque, that's because of the force of contact over here on the wall. And they must be balanced, because otherwise you know, the ladder would not stay there. So therefore this total torque tau 1 plus tau 2 summed up over here, and this anti-clockwise total torque, they must be equal, right? So tau clockwise must be equals to tau anti-clockwise. Therefore you must have F times 4 equals 3000 Newton times meter, and that 4 is a meter, right? So that gives me the force is divided by 3000 divided by 4, and that gives me, so you know, whenever I'm doing the mental math on the class, so this is actually let me show you what I'm doing here. So if I'm trying to divide 3000 by 4, I basically do this 4 and then 3000, so that is less than 4, so it's gonna be 7, right? So that's 7, that's 28, and that gives me 200, so that's 5, right? And then that gives me 20, and there is 1 0, so that's that here, so that gives me 750 Newton. So this is what I do on my head, 750 Newton, and you know, this is Newton meter divided by meter. Meters cancel out, leaves me 750 Newton. I mean, this is using again g equals to 10 meter per second square. When you do g equals to 9.8 meter per second square, I think it comes out about 736 or 740 about, but you know, I mean, this is a rough idea anyway. So so this is how you would solve for the magnitude of the force that the ladder exerts on the wall, that's on the horizontal direction here. Okay, this one in comparison with the other one that for the ladder should give you some idea about how the forces and the torques are basically acting on to you know, create the net balance in this case. I will try to upload another one with similar example. Hopefully this will make sense. All right, good luck guys.